Okay, so last class we discussing about what is hub, what is switch, those things we need to be discussed. So today we'll get to know like what is hub, or another name for hub will be repeater people used to call. What is that? Why do we need this particular device? So think hub is not a intelligent device, nothing but for a hub. If you think there is no intelligence configuration configured in the hub, it's just like a kind of, you can think like forwarder. It will go to just forward an information from one place to another place. A repeater also kind of same, and I mean both are same word only. It is not an intelligent device, it works with bits. You might be aware about what is bit. Bit is a binary digit where it contains 0 or 1s, correct? That's the main use case of the bits. Uses broadcast for communication. There are two types of there, broadcast, unicast. So hub will use for broadcast, so for communication nothing but when you send some information, it's going to send this information to other people, like that. And also bandwidth will be shared. Bandwidth nothing but you can treat like this internet will be shared across to the multiple resources which are connected to this particular hub. Works with half duplex communication. There are two types of duplex communications are there. One is half duplex communication, another one is full duplex communication. What is the difference between each other? What is this difference between half duplex and full duplex communication? Nothing but, so you might be known landline phone, mobile phone, like that, correct? So landline phone, mobile phone, everybody, everything is comes under in a full duplex communication. But what is this half duplex communication then? Half duplex communication nothing but walkie-talkie. Like this police people, some security people which are there in the offices, right? Those guys have a walkie-talkie. What is the significance of that? Nothing but the walkie-talkie is a one-way communication. That means one person need to click on the button and the guy speaks. Once he releases the button, that message will be spread across the multiple peoples. Okay, so that means only one guy can talk at a time. When I am talking, other person can't able to talk. So once I completed my voice, then other person can talk. That is a half duplex communication, one way communication. Kind of we can take like one way. While traveling to the road, one way we can see, right? Only way going vehicles are going, like that. So full duplex nothing but like now you can take this Skype also full duplex. How means I am also talking, you also can able to talk without any disturbance. This is called as a full duplex communication. Understood? Any questions or confusions? You got it right?
Yes, sir.
Next, move on to the switch. Switch, it's an intelligent device. Compared to hub and switch, hub is non-intelligent, switch is intelligent device. So it maintains MAC address table, hardware address we used to call. Remember, what is the significance of this address? Nothing but MAC means media access control address. This is the very important address. Also, people used to call this address as a hardware address or the physical address. What is this use of this particular address? Means, like for example, if you lost your mobile have a IMA number, so that you can hand over that IMA number to police station, so that they can able to search your particular mobile. Is suppose somebody theft or somebody found that. Same way, same way, if you lost your laptop having a MAC address, it's kind of very equivalent to IME number only. Okay, but this is a MAC address. MAC address is a hexadecimal number where it contains 0 to 9 decimal numbers and A to F hexadecimal numbers. Like this, the address will be there. So each port of the switch has its fixed bandwidth, and also it works with flooding and unicasting. So supports full duplex communication. I said, right, person can send the message, person can receive the message at the same time. But hub, it's a single duplex, I mean half duplex. Only person can send, but he has to wait for other persons to receive that, like that. Next, how the MAC address will looks like, and how we can connect a switch. We can see this table. This table will give some clear idea. So look at this main device is the middle device is there, right? Arrows. This is the switch. Then these all computers connected to this particular switch, and once switch is on, once switch is running state, the whatever the pieces are there right here, those all the pieces MAC address will be stored in this particular switch. Switch can read all the MAC addresses. How? Look at here, source MAC, destination MAC, like this number you can see. There I should said right. So the number will be till in decimal come hexadecimal format like that. There could be one table will be there. That's a MAC table we need to call media access control table. So like this port, a MAC address, FA0/1, FA0/2, FA0/3 like this. So each and every, this is the port and the right side one is the MAC address. For an individual computer will have a individual MAC address. Okay, that's the quite advantages compared to hub and switch. Like this, whatever the PCs have a MAC address, those will reflect here. How to see that whether the MAC address is there or not, in what MAC address is there, how do I see that? So we can connect to the switch, MAC address table in switch, so show MAC-add, or show space MAC-address table. If you type like this, then that will going to show us the table, what are the MAC addresses are there and which port was connected. Then third device, router. Yeah.
It will be in the switch. It will be connected through physically, right, sir?
Physically, it will be
Through
connected.
LAN cable.
PCs will be connected to the switch physically. Via wires only we need to connect.
Okay, sir.
I'll show that
And,
practically.
okay.
After this, we discuss theory, right? Then I'll going to show that how to do that. Okay. Next, router. Router is an intelligent device. Remember, router is a very intelligent device. It works with a logical addressing. Nothing but IP, IPX, net, Apple tag, like this multiple parameters we used to call. It works with logical addressing, and it works with fixed bandwidth, like a symbolic representation wise. If you think about like this is the router. Means if you can see here, incoming also there, outgoing also there. But if you look at the switch one, it's only outgoing, no incoming. This is the pictorial representation of the router. If you purchase the router with your own very big router from the Cisco company means, so this is the outer layer of the the 3D text structure of the router, how it looks like means in this format. You can see the right side one, the first one, that's a input power connection. That means a cable. We need to adapt the cable in that so that you can able to communication each other. Then down one you can see PoE, then USB port, USB 2.0 Type A port, RJ45 serial connection console port. You might be aware about RJ45. Why do we need to use means because we need to get the internet, right? For getting the internet, we can use RJ45 cable with connector so that we'll get the internet. Then also we have an auxiliary port also there, and USB serial port, USB 5 pin mini USB Type B, and EHWIC slot right, slot 0 like this. Those are physically we can able to see them. So what is the purpose of this? What are these cables are available? What is the significance of these cables means? Remember, there are two cables majorly people will use. One is straight cable, another one is cross cable. What is straight cable? Straight cable usually use straight cable to connect different types of devices. That means straight cable will use to connect different types of devices, but cross cable used to connect same type of devices. Understand?
Yes, sir.
Straight cable means different devices. Cross cable means same devices. For example, look at it. You have PC. PC to PC you want to connect. Then cross cable. PC to hub you want to connect. Straight cable. PC to bridge you want to connect. Cross cable. PC to switch you need to connect. Straight cable. PC to router you need to connect. Cross cable. Like that. Look at the table. Hub to PC, straight. Hub to hub, cross cable. Hub to bridge, straight. Hub to switch, cross again. Hub to router, straight.
The
Similar
same device mean hub
same
to
thing.
bridge also.
Same routers, nothing but you can assume like this. Two hubs, two PCs, two switches, two routers you want to connect one to one.
Okay.
Like that.
In that time, cross cable you must use.
Similar devices means cross cable. Dissimilar devices means straight.
Okay.
How the background representation looks like this. Straight through means straight away will be there. Crossover means like this will be there. Next. Hope you're clear on this, right?
Yes, sir.
Okay. Next, another important concept in the CCNA is open system interconnection. That's a OSI we used to call. OSI ಅಥವಾ IOS, ISO, International Standard Organization. International Standard Organization. So, what is the significance of this? Means, uh, for example, when you turn on your PC, when you turn on your Wi-Fi, how you will get the internet? For you, just you will be turning on the Wi-Fi and you will be able to access the internet. Correct. But in the background, there are many things will be happening. In the background, there are plenty of things are there. Those we want to be understand. So those will be derived from the word called OSI, Open System Interconnection Layers. It is come up with 7 layers. In the overall world, any place you can go, these layers are standard layers. This never change, never change. For an example, OSI was developed by the International Organization for Standardization, ISO. OSI was developed by ISO, International Standard Organization, and introduced in 1984. This ISO is introduced by 1984. It is a layered architecture. That means consists of 7 layers. Remember, guys? So this is the layering part. So it contains 7 layers. It has 7 layers. So it will work with the principle called 7 layers only. Make sure. We'll go to describe that what are those layers. Okay. Make using this layers only will be understanding and we'll get to know how the internet will be reachable to the end level. Those will be described from this one only. Next. Each layer defines a set of functions which takes part of the data communication. That means this 7 layers describes that how data will be transferred from one place to another place. So based upon that only that the networking concepts also works and it will going to take the data to the predefined set of ways. So what are those 7 layers? Look at this diagram. This diagram will give you some clear understanding of what are those types of layers are there. So if you can see the first layer, that is physical layer. Second one, data link layer. Third one, network layer. Fourth one, transport layer, session layer, presentation layer, then application layer. So always remember, while reading OSI models, or while reading OSI layers, you need to read from bottom to top, not like top to bottom. That's a consequences. So you need to be ready from the layer 1 to layer 7. So how internet will come from? Internet things will start from layer 1 only. Layer 1 is a physical layer. The name itself is there, physical, nothing but physical components. It only consists of the physical components. So for an example, you might be aware about the wire, RJ45 wire, RJ11 wire, like that cable, that is comes under in physical layer. And hub is a device which you discussed, right? Hub is also comes under in physical layer. That means majorly one word I want to say means physical layer consisting of non-intelligent devices. Remember, physical layer consisting of non-intelligent devices. Then we have a data link layer. Data link layer is an intelligent device. That means switch will be comes under in data link layer. And network layer, router will come into the network layer. Network layer is something like a big boss for this remaining two. That means all together people used to call network support layers or hardware layers. These three only contains the hardware components. Like hub is hardware component, switch is hardware component, and router is hardware component, right? So make using these components only. The all together they used to call as network support layers. Clear? Next, next we have a next layer is fourth layer is transport layer. This is a very important layers where this will the name itself is a transport. Means core layer of the OSI, and along with this, we're going to deal with the port numbers. We are aware about the port numbers, right? 22 for SSH, 80 for HTTP, 443 for HTTPS, like that. Those will be described by this transport layer. Then what is session layer and presentation layer, application layer? These are the user support layers or software layers people used to call. Below down 3 are the hardware layers, above top 3 are the software layers. The middle guy only core layer. Okay. Any questions?
No, sir. Good.
Then what are the things will comes under in that? So remember, you used to the browser and you'll type when you connect Wi-Fi. Remember, when you connect Wi-Fi to your PC or laptop or your mobile, you used to go to the browser and you will type some of the URL like www.besantechnology.com or www.google.com, infosys.com. Like this, you used to type the command, type the URL, correct? So that means you noticed one thing here. The URL was started from www, correct? Or else the URL can start from HTTPS. The URL might be start from HTTP. Other than these three, none of the URL starts with anything else. That means these three components which I said, right? HTTP, HTTPS, www. That is called as application layer. So application layer is responsible for providing an interface for the users to interact with the application services or networking services. For example, web server, HTTP, telnet, SSH, etc. Then what are the different types of services are there? I said the port numbers, right? Remember these port numbers, guys, because in the interview they'll ask about these port numbers only. HTTP means 80, FTP means 21, SMTP means 25, telnet is 23, TFTP means 69. Like this, the port numbers are there. We can make use these port numbers.
So TFTP means, sir?
Trivial file transfer protocol. FTP means only file transfer protocol, correct? TFTP means trivial, TRIVIL, trivial file transfer protocol. This is also kind of FTP only, but a little bit security will be there in that TFTP. Then data flow from application layer. How the data will flow means, look at the port numbers there, 80, 20, 25, 53, 67, 69. When application layer, in the application layer, we used to enter the your URL, right? Either the using one of the port number. So if you enter that, that will go to presentation layer as a data. Then next, presentation layer. Presentation layer is responsible for defining a standard format to the data. It deals with data presentation. The major function described at this layer are encoding and decoding. That means presentation layer moreover handling the data in the encoding or decoding format. So for an example, ASCII, EBD, EBC, DIC, JPEG, GIF, TIFF, MIDI, WAV, MPEG, DAT, AVI. These are the standard formats which are available for the encoding and decoding. Then encryption, decryption, compression, decompression. This all the sort of things will be done by presentation layer. Next, how data flow will happen? Application to data, presentation data will come. From presentation data will go to session. Session layer is responsible for establishing and maintaining the terminating the sessions. Session ID is used to identify a session or interaction. Example, RPC, remote procedure call, or SQL, standard structured query language, ASP, Apple Tax Session Protocol. Like this, these are the things that are going to be made a session for interacting with other services. That's the place session layer is coming to picture. Once data is moved, finally we'll come to network transport layer. Transport layer is provides data delivery mechanism. Remember, transport layer provides It provides data delivery mechanism between the applications in the network. The major functions described at the transport layer are identifying a service, multiplexing, demultiplexing, segmentation, sequencing, reassembling, error control, flow control. Like this, plenty of parameters are there. Those will be supported by transport layer. Then identifying a service. Identification of a service is done using port numbers. Port is a logical communication channel. Remember, port is a logical grouping of the number. Total port numbers, how many are there? 0 to 65,535 is there. Reserved ports are 1 to 49,151. Remember, reserved ports are 1 to 49,151. Then open ports are 49,152 to 65,535. These are the standard port ranges which are available in the transport layer. Multiplexing, demultiplexing, how it happens? Multiplexing and demultiplexing are the two important functions that are performed by transport layer. Transport layer at the sender side receives the data from the different applications, encapsulates every packet with a transport layer header and pass it on the underlying network layer. This job of transport layer is known as a multiplexing. At the receiver side, the transport layer will do demultiplexing. Example, suppose you are sitting in front of your computer and you are downloading web pages while running one FTP session and two telnet sessions. You therefore have four network application processes running, two telnet processor, one FTP process and one HTTP process. So when the transport layer in your computer receives the data from the network layer below, it needs to direct the received data to one of the these four processes. Let's examine how it is done like this. So the protocol which take care of data transportation at transport layer are TCP and UDP. Make sure guys, these two are very important and very frequently asked question in the interview also. What is the difference between TCP and UDP? TCP, transmission control protocol. UDP, user datagram protocol. Connection oriented, connectionless protocol. Supports acknowledgement, does not support any acknowledgement. Reliable communication, unreliable communication. Slower data transfer rate, faster data transfer rate. Protocol number is 6, protocol number is 17. HTTP, FTP, SMTP. When it comes to UDP, DNS, DSCP, TFTP. These are the major differences between UDP and TCP. For an example, segmentation, sequencing and reassembling, how it works. Segmentation and reassembling wise, if I talk about, a message is divided into segments. Each segment contains sequence number which enables this layer in reassembling the message. Message is reassembled correctly upon arrival at the destination and replaces packets which were lost in the transmission. Remember, you have a data. You data is hello, how are you is a data. Okay. So now, while sending the data, generally all together it won't send. Remember, while sending the data all together we won't send. So one by one, hello one time, hello how one time, how are you one time, like that only in the series header it is going to send that. So look at how are you question mark, like that. So then data will be received by the end place. Like it will convert as a packets, segments. See 1 bar 5, that means 5 characters are there, 1 bar 5. 2 or 3 characters are there, means 2 bar 5, 3 bar 5, 4 bar 5, 5 bar 5. Nothing but it will convert as a sequence order, and along with make using the sequence it will going to be sent. So first this one will go, next that will go, next that will go, like that. Next, network layer. Network layer is provides logical addressing and path determination. Remember, network layer provides logical addressing and path determination routing. The protocol that works is this layer are routed protocols, IP, IPX, AppleTalk, etc. Routed protocols used to carry user data between the host, kind of RIP, OSPF. Anyway, these both will discuss in detail about in the network layers in upcoming class. And also, routing protocols performs path determination. That means the main purpose of the routing is that finding the best path. Remember, what is the significance of this means? What is the use of this network layer? What is the use case of routing means? It will going to determine the best route. It will going to determine the best route. Just a minute. Next, data flow from network layer. How data flow will happen? Device that works at network layer is router. Okay. Look at transport layer means segment. Network layer means packets. Then next we have a data link layer. It has two sub layers also there. Data link layer is main layer. Inside this main layer, there are two sub layers are there. One is media access control. It provides reliable transit of the data across a physical link. It also provides the error detection using CS, cyclic redundancy check. Example, Ethernet, token ring, etc. Another layer is logical link control, LLC. It provides communication with the network layer. It provides communication with the network layer. That means one is media access control layer, another one is LLC layer. Data link layer will use frames to send the data. Final last one, physical layer. Physical layer, it defines the electrical, mechanical and functional specifications for communication between the network devices. The functions described at this layer are encoding and decoding both. It is a process of converting the binary data into a signals based on the type of the media. For example, copper media, electrical signals of the different voltages, fiber media, light pulses of the different wavelengths, wireless media, radio frequency waves. Like this, only majorly physical layer will deal with the physical components, majorly wires it will be dealing. How the things will work? Look at here. Devices that work at a physical layer are hub or repeater. That means that's the reason physical layer we used to call it as a bits, binary digits. So then we have a OSI layers, and along with that TCP over IP model. So that means so far we discussed about OSI model, OSI layers, correct, 7 layers. But later when they implemented 1984 or some way, so there are 7 layers was there. Later, gradually, when the technology leading, so people started TCP over IP model. Now TCP over IP model is more popular. What is this difference each other means? It was reduced some of the layers from 7 layers to 5 layers only majorly, or the 4 layers. If you can see below, the physical layer, data link layer, both combined as a network access. Remember, physical data link, both combined as a network access. Network layer converted as a internet layer. Network layer converted as a internet layer. Transport layer is called as host to host. Transport layer called as host to host. Application presentation session, all three configured as an application. Then lot of layers will be saved, lot of time will be saved, and lot of code will be saved. Got it? Then how we can set up a LAN cable? Generally LAN, how the LAN setup will be there. Like this, we can able to open your laptop and we can able to set up the IP ranges. You can see 192.161, 1.1, 1.2, 1.3, 1.4. Like this, we can able to configure. Next, we have a IP addressing will be there. So IP address is a logical address. It is a network layer address. Layer 3 we used to call. Two versions of IPs are there. Remember, two versions of IP, IPv4, IPv6. IPv4 is 32-bit, IPv6 is 128 bits. Remember, this we need to be remember. So we have a two versions, IPv4 and IPv6. IPv4 is 32-bit address, IPv6 is 128-bit address. So then IPv4 version, if we talk about, a bit is represented by a 0 or 1. Bit is a binary digit represented by 0 or 1. IP address in binary terms are 32 bits. Any value take, you need to write that value in the binary format, 0 or 1 format. So 32 bits are divided into 4 octets: first octet, second octet, third octet, fourth octet. Like this will take the IP address in the decimal format. If I convert, you wrote in the binary format, right? If I convert that to decimal means this much IP range will come 85.5.191.1 like this. It should be in a 84, I mean this format, decimal format, so that it will appear in the valid range. Then IPv4 address range, if I talk about, taking example for first octet, total 8 bits are there, value will be zeros and ones, 2 to the power of 8, 256 combination. Okay, like this we can write it in the binary format. This is a binary, this is a decimal. Like might be you are aware about 8421 code in the logic design, right? By first year, first class. I mean, basic electrical and electronics subject will be there, right? There you might be the teacher about this.
Yes, sir.
How to convert binary to decimal. 8421 code 0000 0001 0011 like that. Like if you look at these values, 128 plus 64 plus 128 plus 64, if I calculate 192 will get. So like this binary decimal table, if you recall, we can able to conclude this. Decimal to binary, this one.
Based on like 2 to the power of 0, 2 to the power of 1.
2 to the power of 0, 2 to the power of 1, 2 to the power of 2, like that. 2 to the power of till 7.
7. Yes.
Classification of IP. IP is subdivided into 5 classes: A, B, C, and D and E. Make sure we are using only ABC. Use it in LAN and WAN. But D and E, where it is using? D used for multicasting, E used for research and development, R&D. So priority bit. Priority bit is used for IP address calculation, classification. Most significant bits from the first octet are selected as a priority bits. Like they might be said the word MSB, LSB. Most significant bit, least significant bit. Most significant bit means the starting point of the IP address. The left side, what range you see, right? That one. Least significant bit means the right side number. So we always look for left side number only. So class A priority bit is 0, class B priority bit is 10, class C 110, or class D 1110, then E 4 ones, like this. You can see in class A, the first of the first octet is reserved as a priority bit, but bit value is 0. Then the last one is 127, 125, 255, 255, like this. I mean, if you can see this one, first is a desired value, you can ignore that. Then the next values will be calculated. Class B, both the values will be priority bits. Like this, you can ignoring this. That's the reason starts from 191. See, third one 110, 223 will start. Then 1110, 239, then 255, like this. Range we need to understand. This is the actual range. You need to remember this range only. In the interview also, this ask about this range only. What is the IP address classification? What are the different types of IP ranges that there means? You need to be denotify this one only. A range, B range, C range, D range, E range.
So based on priority bit only, they classify the ranges, right, sir?
Correct. In the first A, first priority is 0. That's the reason the IP address will start from 0 to 127. Second one, priority bit is 2 digits, 10. That's the reason it start from 128 to last end with 191. C, 192 to 223. D, 224 to 239. 240 to 255. Like this, the range we need to be calculated. Now, looking at this IP address, we need to judge that which IP address belongs to which class. So 10, we always remember first digit only will be referring, right?
Yes, sir.
That's the reason. First one class A, 150 is class B, 192 is C, 224 is D, and 120 is A.
Okay.
Then octet format. IP address is divided into network address and host portion. Class A is written as NHH. Remember here, one N means one network, 3 host. B is HHNN, 2 networks, 2 host. But class C is 3N, 1H, 3 networks, 1 host. Then this is we need to apply the formula. I'll show this formula application in the next class. So because already we discussed many theory. For today's class, what you going to do, Amod? You create like in the internet, you refer some of the IP addresses. In internet,
Okay, sir.
refer some of the IP addresses. So then you like you note down those IP addresses in your notebook or somewhere, and you write down in the right side. So the IP address is valid, or I mean which class this IP address belongs to, and along with that, if the IP address is valid or not, you judge it. You just mention.
Okay.
Remember, how do you know the valid IP or not means the range IP range will be there, right?
Yes, sir.
The range of the IP address maximum 255 only. Above 255 should not be there. And
Yes, sir.
the
Yes.
value whatever you can see, right? So if 10 like this, 10, 1, 1, 0, 0, 1 like that is four values are getting up, right? That's each
Yes, sir.
value less than 255. It could be 255, it less than 255. Make sure. Not more than 255. If you more than 255 is the invalid address. None of the IP address in the world there 255, 256, 257 like that. Okay. You calculate that first. Note down what is,
Sir,
I mean, A, B, C, D, E. Then post that you write down some of the IP addresses. Then you mention that this IP address belongs to which class, and along with that, whether it's a valid IP address or not. You do that experiment for right now. I mean, for this.
okay, sir.
Then next class, I'll apply the formula how to calculate the number of IP address. I'll show in the next class.
Okay, sir. Sir,
After
2 to the
calculating that,
power of 8 is the maximum rate, sir.
that's a 248 is the maximum. 248 if you calculate, you will get
256
246.
and 255.
Correct. 256 you will get, but minus 1 you will be doing. That's, I mean, we'll calculate from 0, right?
Yes, sir.
256 will be written from 0. 0 means it 0 to 255. That means 256 will get right total value. Like
Yes, sir.
that.
256.
Yeah. Next class we'll start the practical. So related to hub and switch and calculating the IP address, those things we'll do. Okay.
Okay, sir.
Any questions, Amod, for this
No,
student
sir.
today? Nothing?
No, sir. Yes.
Okay, cool there then. Next class we'll discuss about the checking the IP address configurations, and along with how to configure those, we'll see that. Okay. Thank you.
Okay, sir.